Hey everyone, in this video we'll learn how to solve a system of nonlinear equations. So let's write down an example of one. Let's say we had y minus x equals -2, and we also had the square root of x plus 4 equals y. Perfect, so we have these two equations, and although this first equation over here is linear, this second equation is not linear. This is a radical equation because there's a radical x plus 4 here. So this works a little bit differently when we go through the steps of trying to solve this. But it's the same process. We're going to try to solve this by substitution. And as you can see right here in this second equation, y has already been solved for us. Y is isolated. So now that y is isolated, we can actually plug y. We can actually substitute radical x plus 4 into the y in the first equation. So we can rewrite y minus x equals -2. We can rewrite that as radical x plus 4 minus x equals -2. And all I did was substitute the y for radical x plus 4. And then we can continue to solve for x. We can go ahead and just move the x to the other side. And the reason we want to do that is we want to get the term, or we want to get the radical isolated, x minus 2, because once the radical is isolated, we can square both sides. So let's go ahead and square both sides. And squaring a radical will get rid of it, so the radical and the square will cancel out. We are left with x plus 4 equals, and then you have x minus 2 squared. So you have a binomial squared. You can use FOIL to multiply this out, but if you do, this comes out to x squared minus 4x plus 4. Great. And let's keep going. So let's go ahead and actually move all these terms to the other side. So we can subtract x from both sides and subtract 4 from both sides. And we have 0 equals x squared, and then minus 4x minus x is minus 5x, plus 4 minus 4 actually cancel out. So we have x squared minus 5x equals 0. Perfect. So what we can actually do now is factor an x out of here. So x times x minus 5. We can go from here to here by factoring an x out. So we have x times x minus 5. And now we have multiplication of two things, x times x minus 5 equaling 0. So what that means is we can split this up. We can split this up into two different equations, x equals 0 and x minus 5 equals 0. So we have x equals 0 and then x minus 5 equals 0. And right here we've solved for one, x equals 0. Perfect. And then in this equation we can just take one more step by adding 5 to both sides. And we have x equals 5. Okay, now we solved for x, but we got two solutions for x. So in order to solve for y, what we usually do is plug x, the value we got for x, we're going to plug it back in to one of these equations. So let's actually do that with both of them. So let's start with x equals 0. We'll start with this one. And we're just going to pick an equation up above. I will pick this one, y minus x equals -2. So y minus x equals -2. Let's go back here. Y minus x equals -2. And we know x is 0. So this comes out to y minus 0. So y minus 0 equals -2. And y minus 0 is just y, so that's it. Y equals -2. And there we go. So we've solved for an x and y pair, 0 and -2, on this left side right here. And now we're going to solve for y again using x equals 5. So we can go ahead and use the same equation right here, y minus x equals negative 2. So y minus x equals negative 2. And we're going to substitute this x for 5. So this comes out to y minus 5 equals negative 2. And to solve for y, we'll just add 5 to both sides. We have y equals negative 2 plus 5 is 3. There we go. So we have these solutions for x and y. On the left side, we have 0 and negative 2. So we can write this as an ordered pair, 0, comma, negative 2, right here. And then on the right side, we have 5 and 3, which we can also write as an ordered pair, 5, comma, 3. Since 5 is the x value, 5 is the x value up here, and then 3 is the y value up here. And same thing on the left, right over here. 0 is the x value, and our y value is negative 2. But we're not done yet. Although we solve for x and y, we actually have to test for extraneous solutions. And the reason is because we have a radical x plus 4 here, which could cause us issues. We have this radical x plus 4 equals y. So let's actually test for extraneous solutions by plugging these solutions back into both of these equations. So let me go ahead and copy both of them so that we have them again. Put them down here. And let's start with the left side. So let me just go ahead and just increase this. 1 second. There we go. So let's start with the left side. So what we're going to do, we have our solutions 0 and negative 2. X is 0 and y is negative 2. So let's first plug it into this first equation right here. Y minus x equals negative 2. What is y? Our y is negative 2. So our y is negative 2 minus, and what is our x? Our x is 0. So our x is 0, which we'll plug into here, equals negative 2. Negative 2 minus 0 is negative 2, equals negative 2. And that's true. Negative 2 equals negative 2. So it passes the test for the first equation. But now we have to test this second equation right here. Radical x plus 4 equals y. So let's go ahead and write that one down. So for the first equation, it passes, so I'll give it a check mark. And for the second equation, radical x plus 4 equals y. What is our x? So radical, our x is 0, so we'll put a 0 there. So plus 4 equals, and our y is negative 2, so we'll put a negative 2 there. And then what is 0 plus 4? 0 plus 4 is 4, so radical 4 equals negative 2. And what's the radical 4? What's the square root of 4? That's 2. 2 equals negative 2, which is not true. 2 does not equal negative 2. So what that means is that this ordered pair right here, 0, comma, negative 2, this is extraneous. So that's extraneous. But let's go ahead and test the right side. Let's see if this is extraneous. 5, comma, 3. So we're going to do the same thing. We'll test the first equation. So our first equation was y minus x equals negative 2. So let's write that down here. Y minus x equals negative 2. What's our y? According to this ordered pair, our y is 3. So 3 minus, and then our x is 5. So our x is 5 equals negative 2. 3 minus 5 is negative 2. Negative 2 equals negative 2, which is true. That is true, so we will give that a question mark. or we will give that a check mark rather. Negative 2 is negative 2. So it passes the first equation. But now let's test the next equation. Radical x plus 4 equals y. So let's go back down. Radical x plus 4 equals y. What did we say x was? We said x was 5. So we will write radical 5 plus 4 equals, and we said y was 3 equals 3. So let's evaluate this. What's 5 plus 4? That's 9. So radical 9 equals 3. And then what's radical 9? Radical 9 comes out to 3. So 3 equals 3, which is true. 3 does equal 3. So that means this ordered pair right here, it passes both equations. It works for both of the equations in our system of equations. So these are the only solutions. So 5 comma 3, or in other words, x equals 5, x equals 5, and y equals 3. Those are the solutions to this system of nonlinear equations that we started with. So I hope this video helps, and if you have any questions at all, please leave them down in the comments below. Thank you for watching.